Hello friends, welcome to video series on geography. Till now I have covered important topics of geomorphology ranging from Earth's interior to erosional landforms. There are few important topics like plateaus, plains and important river systems across the world and mineral distribution, etc. All these topics I'll be dealing in a section called World Geography after finishing Indian Geography. For time being I'll be covering climatology and then oceanography. And once oceanography is done, I'll be dealing with Indian geography. And once Indian geography is done, we'll discuss about all the leftover topics of geomorphology, namely plains, plateaus, river systems, etc. and various mineral distributions all across the world as well as India. This will be covered under World Geography. In this video, I'll be explaining about latitudes and longitudes, which forms the fundamental concept of climatology. So understanding latitudes and longitudes is important to better understand climatology. So in this video I'll be explaining about heat zones, day and night, seasons and standard time. First, what are latitudes and longitudes? Latitudes and longitudes are imaginary lines on the Earth's surface. As it said, they are imaginary, they don't exist in reality. These are just created for our convenience. Latitudes are horizontal imaginary lines, whereas longitudes are vertical imaginary lines. Let's see in detail. Let's look at the comparison between latitudes and longitudes. Latitudes are also called as parallels. That is because each latitude is parallel with every other latitude. Whereas longitudes are called as meridians. Meridians are simply lines that run from pole to pole, that is from North Pole to South Pole. These lines just simply join North Pole and South Pole. They're not complete circles like latitudes. Latitudes are part of complete circles that circle round the Earth along its surface, whereas the longitudes are simply a line joining North and South Pole. Latitudes are measured as angular distance of a point from the center of the Earth, that is angular distance from center of the Earth. This is the center of the Earth. From here we measure the angular distance from this center, and this angular distance specifies the position of certain latitudes, and the longitudes are angular distance along the equator. But while measuring longitudes, we take the angular distance along the equator, that is, we know that this is the equator, so the longitudes are measured as angular distance along the equator. And the equator is called 0° latitude, and it is the biggest latitude. It cuts the Earth into two equal halves, that is two equal hemispheres. For example, this is first northern hemisphere, this is southern hemisphere, and the equator is the biggest circle that cuts the Earth into northern and southern hemispheres. Whereas the prime meridian is 0° longitude. It passes through London, a village called Greenwich, hence this is called as prime meridian, which is taken as a reference meridian. Unlike latitudes, this is not a complete circle, this is simply a line joining north and south poles. Latitudes are named south and north of equator, that is, when we consider a certain latitude, we name it by telling either its location is north of the equator or south of the equator. For example, if this is 10 degrees, it makes 10° angle with the center of the Earth, then it is called as 10° north latitude. And the same thing if it's in the south of the equator, then it's called as 10° south latitude. And longitudes are named east or west of prime meridian. For example, all along the equator, this angular distance is made by a longitude, and let this longitude be about 30° or a 40° longitude, then we call it east of the prime meridian. And if the same thing is west of the prime meridian, then we name it as 30° west of prime meridian. And as we have said, equator has the maximum length, whereas in longitudes, all longitudes are equal in length. We can see that equator is the longest latitude, whereas when we move upwards towards the North Pole or towards the South Pole, we see that the latitudes become shorter and shorter, and at North Pole it becomes simply a point. Even this is an example for latitude, which is a point latitude. That is, in North Pole it is simply latitudes are simply a point, both at North Pole and South Pole. But if you take a look at longitudes, they are the same. They are equal in length. All the longitudes are equal in length, and they connect South Pole and North Poles. And the important latitudes are Tropic of Cancer, which is 23.5 degree north. So somewhere here, 23.5 degree north. It runs to India. It cuts India into nearly 2 equal halves. And the other one is Tropic of Cancer, which is 23.5 degree south latitudes. Other one is Arctic Circle and Antarctic Circle, which are respectively 66.5 degree north and south latitudes. And the North Pole and South Pole, which are point latitudes, which are the extreme ends of latitudes, that is, they are the point latitudes. And the important longitudes are prime meridian, which is 0 degree longitude, and the other one, which is exactly on the opposite side of this meridian, is called as international date line. It is 180 degree east or west longitude. These two longitudes are important. We'll see why. And there is a purpose why these imaginary lines are drawn, and let's see why how these things help. First thing, longitudes help in determining the intensity of sunlight received at a point. We'll see in detail in the later part of the video. They divide Earth into torrid, temperate and frigid zones. We'll see this in later part of the video. And the longitudes are used to determine time and date. And both these longitudes and latitudes are important in determining the location of a point on the Earth. Hence, the main purpose of longitudes and latitudes is to determine or specify the location of a point. Let us first take a look at different motions of Earth. The first important motion is rotation, where Earth rotates along an axis that runs from North Pole to South Pole. The other important kind of motion is revolution, where Earth revolves around the Sun in a fixed orbit, which is elliptical in shape. It is not circular but elliptical, and this plane in which Earth revolves is called as orbital plane. And Earth makes an angle of 66.5 degree, or the axis makes an angle of 66.5 degree with the orbital plane. Hence, the Earth is said to be tilted by an angle of 23.5 degree. Earth takes about 24 hours to complete one full rotation. To be precise, it is 23 hours, 56 minutes and 4 seconds. Likewise, Earth takes about 365 days to complete one full revolution, and precisely it's 365 days and 6 hours, or 365.24 days. That is, for convenience, we exclude this extra 6 hours. We consider a year as only 365 days. Likewise, when it comes to rotation, we take that the Earth rotates in 24 hours instead of 23 hours, 56 minutes and 4 seconds. And this surplus 6 hours is compensated by every 4 years with a year called leap year, where the year has 366 days. 6 into 4 will give rise to nearly 23.99 something hours, that is one full day. Hence, this one day is adjusted during a year called leap year, which has 366 days. The one day is adjusted to as 29th day of February in that year. So for convenience, we have excluded the extra hours, and finally, to make up for the error, we have added the same extra surplus time, giving rise to a leap year. And these motions of Earth, namely rotation and revolution, are the major factors which influence climatic conditions on Earth, as these motions are associated with differential reception of sun's energy. The climatic factors on Earth seem to be completely dependent on these motions along with the spherical shape of the Earth. For example, Earth being a sphere, there is differences in amount of heat energy received at different curvatures. For example, at the equator, which faces directly towards the sun, the heat energy received is higher, whereas at the poles, due to curvature, the poles face towards certain much different direction, not towards the sun. As a result, apparently it looks like sun's rays are slant. As a result, these polar regions receive less amount of heat, and this differential heat reception is the main factor behind various climatic conditions like precipitation, cyclones, anticyclones, jet streams, etc. So finally, climatic conditions directly or indirectly dependent on both the movements of Earth or the motions of Earth as well as the shape of the Earth. And days are a direct consequence of rotationary motion of Earth, and seasons are direct consequences of revolutionary motion of the Earth, where the Earth is tilted by a certain angle, that is, the axis makes certain angle with the orbital plane. These two factors greatly influence the amount of insolation or the amount of heat, sun's heat energy received. We'll see these further. Let's first look at heat zones of the Earth. Heat zones mainly depend on the amount of insolation or the amount of sun's energy received at different latitudes. For example, the latitudes around the equator receive direct sunlight as the curvature here is directly facing towards the sun, and apparently sun's rays looks direct, whereas in this part the curvature is facing towards this direction. As a result, the sun's rays in the higher latitudes seems to be slant or covering a large amount of area. As a result, the heat reception is comparatively lower in the higher latitudes. Hence, these regions are comparatively less hot compared to the equator. Based on this differential reception of sun's light, there are different temperate zones, that is zones of heat zones, which are part of Earth. For example, torrid zone is the zone between Tropic of Cancer and Tropic of Capricorn, where sun's rays is falls directly at least once in a year. The other one is temperate zone, and there are two temperate zones, one in the north and one in the south. The north one is called North Temperate Zone and the other one is South Temperate Zone. They are regions between Tropic of Cancer and Arctic Circle in the northern hemisphere and Tropic of Capricorn and Antarctic Circle in the southern hemisphere. These regions receive slightly slant rays due to their curvature, that is the shape of the Earth. As a result, the temperatures in these regions are comparatively lesser when compared to the equator. As a result, these regions are called temperate zones, where temperatures are moderate. And in the next zone, that is frigid zone, which is part of Arctic and Antarctic Circle, they are very cold because of very least amount of sun's energy received here. That is, sun's rays are very slant, and as a result, the amount of energy received per area is very low, and hence the temperatures here are extreme, that is very low. So we know that days and nights are mainly due to rotation of Earth along its own axis, that is north-south axis. But we also know that during different parts of the different times of the year, the length of day and night varies. So let's see why this variation occurs. First, let's study seasons to understand these variations. Seasons are a direct consequence of revolutionary motion of Earth, where Earth revolves around the sun with a fixed position of its axis. We see that the position of the axis is fixed in all these positions. That is, the angle it makes with the orbital plane remains same, and also its direction remains same. On 21st June, that is when northern hemisphere is facing the sun, the northern hemisphere receives direct sunlight due to this tilted position. Otherwise, equator has to receive direct sunlight as it is the central part of the Earth. It is the central position of the Earth, but due to this tilt, northern hemisphere faces the direct sunlight, and the southern hemisphere and the equator receives slightly slant sun rays. As a result, it is summer in northern hemisphere and winter in southern hemisphere, and this position is called as summer solstice for northern hemisphere and winter solstice for southern hemisphere. And exact opposite position occurs on 22nd of December, where the southern hemisphere receives direct sunlight and the northern hemisphere receives indirect sunlight. As a result, it will be summer in southern hemisphere and winter in northern hemisphere. Hence, this position becomes winter solstice for the northern hemisphere and summer solstice for southern hemisphere. And during other months, on 21st March and 23rd September, both southern hemisphere and northern hemisphere receives slant sunlight, whereas the equator receives direct sunlight. That is, in both positions, equator receives direct sunlight, northern and southern hemispheres receive slant sunlight. As a result, the temperatures in both northern and southern hemisphere remains the same, whereas at the equator the temperatures are extreme. And these seasons are called as this position is called as equinox. For the northern hemisphere, the month of the day 21st March will be spring equinox, and for southern hemisphere it will be autumn equinox, and vice versa. Likewise, the position on 23rd September, these two positions are equinox positions. where the equator receives direct sunlight and the poles, that is northern and southern hemisphere, receives slant sunlight. So due to this differential reception of sunlight over a period of year, there are different seasons that occur, that is summer, winter, autumn and spring. And due to these different seasons and that is varying sun's rays, there are different pressure belts and wind systems created on the Earth's surface, in the Earth's atmosphere, which results in precipitation and various other climatic factors. And also we know that Earth revolves around the Sun in an elliptical orbit. So ellipse is a figure which has two foci and a line passing through these two foci, which is called as major axis, and this is the center, and one more line, it is called as minor axis. Ellipse is slightly different from a circle, that ellipse has an eccentricity, that is the ratio of major and minor axes. Okay, let's not go deep into that. But according to Kepler's laws, if Sun is at one of the foci, then Earth revolves around the Sun along this orbit, that is along the elliptical orbit. As a result, there are two kinds of distances where the Sun is closest to the Earth, that is here, the Earth is closest to the Sun and the Earth is farthest from the Sun. This position is called as aphelion and the shortest position is called as perihelion, and the respective distances are called as apogee and perigee. So for the revolution of Earth around the Sun, the apogee is 152.6 million kilometers, whereas the perigee is only about 147 million kilometers. Hence, due to variations in these distances also, the amount of sunlight received during these two periods, it is quite different. For example, apogee occurs on July 4th every year, that is around July 4th. It might be one day closer or farther, and other position called perigee occurs on Jan 3rd, or sometimes it might be Jan 4 or 2nd or 5th. It varies by 1 or 2 days. So this point is called as apogee and this position is called as perigee. Hence, during Jan 4, the Earth would receive comparatively less amount of sunlight as it is farthest from the Sun, and during July 4, it will receive less amount of sunlight, whereas during Jan 4 it will receive more amount of sunlight as it is closer to the Sun. So the major factors that influence the climatic conditions on Earth are rotation of the Sun, rotation of the Earth along an axis, tilted axis, and revolution of Earth around the Sun. Even here, the position of the tilted axis remains the same, hence this results in change of seasons. And also, the Earth revolves around the Sun in an elliptical orbit, and elliptical orbit results to two positions, one is apogee and perigee, as we already discussed. And due to these factors, there is different amount of heat received by the Earth from the Sun, that is insolation varies with seasons, rotation, that is days and nights, and also position of the Earth. Hence all these factors directly or indirectly influence climatic conditions on Earth. So we have discussed about days and nights, the occurrence of days and nights and seasons. Now let's see why the daytime and nighttime varies with seasons. For example, let us consider the situation on June 21st, that is summer solstice for the northern hemisphere. We can see that due to this tilted axis, the northern hemisphere receives direct sunlight, whereas equator and southern hemisphere receive slightly slant sunlight. And as a result, we can see that this one line which separates dark zone from bright zone is called as line of illumination. If you can see this, there is certain parts of Earth which are beyond this axis, but still they are brighter because of this tilt. As a result, these regions, that is all these parts of the northern hemisphere, here it's the days are longer compared to nights in summer season. The exact opposite happens in winter season. This is due to majorly the tilt of Earth. This tilt by an angle of 23.5 degree is the major reason between the different times of day, different lengths of days and nights during different seasons. Likewise, if you see in the southern hemisphere, we can see that though this region lies in the first half, but still we can see that certain parts of this region is beyond the line of illumination, that is, it is darker. This is because of the tilt again. You can see the tilt has resulted in this place, which is in the first half also to become darker. And we can see that the northern the Arctic Circle is under perpetual sunlight as it is tilted towards the sun's rays, and the southern hemisphere is in perpetual night, or there is no sunlight for about 6 months in this region, in this whole region, as the earth is tilted away from the sun. And the exact opposite happens in winter season, where northern hemisphere, that is Arctic Circle, is in darkness, whereas the Antarctic Circle will be in perpetual daylight. So these important features are mainly due to the tilt of the earth and the revolution of this tilted earth around the sun. This is one important concept called daylight saving time, which is observed in few countries like USA, Canada, etc., and most of the countries which are in higher latitudes like European nations, Russia, and few other nations. India doesn't adopt this kind of daylight saving time. We'll see what this is. Due to differential amount of that is different time lengths of days during summer, we know here in daylight saving time zones, they simply advance their clocks by 1 hour so that they could work 1 hour earlier and end the work 1 hour earlier. So by the way, by this process, they are going to save 1 hour, which can be used for other recreational activities. Moreover, by doing this in the night times or in the evenings, they save 1 hour of electricity by going to bed 1 hour early, because as all the activities are completed 1 hour earlier, even going to bed will be 1 hour earlier. As a result, there is about 1 hour saving of electricity due to switching off of various lights, etc. So this is one productive step taken during crisis situations like wars, etc. But even now this is followed in some countries. In India, we don't follow this daylight saving system. Now let us take a look at other important concepts like Greenwich Mean Time, Standard Time, and International Dateline. All these concepts are mainly associated with longitudes. Longitudes are imaginary lines that pass from North Pole to South Pole. So the longitudes are mainly used to determine time and date all across the globe. And in a globalized world, each country cannot follow its own time system or a date system, so that it would lead to chaos where every country follows its own type of date and time system. So to bring in uniformity, the longitudes were first envisaged, and by using longitudes we could determine time and date with respect to a certain location. And this certain location is Greenwich, that is prime meridian, which passes through Greenwich in London. In 1884, it was decided that this line would be the prime meridian. As British were ruling all over the world, they were dominant, and they got to decide which line would be the prime meridian, and they chose the one which passed through Royal Astronomical Observatory, Greenwich, near London. And to attain this uniform date and time system, the Earth was divided into 24 longitudes. We know that Earth is a sphere, and from above it would look like a circle, and circle would make an angle of 360 degree. So now this 360 degree corresponds to 24 longitudes, and each longitude corresponds to 1 hour. So 24 longitudes corresponds to 24 hours or 1 day. So when 360 degree corresponds to 24 longitudes, then one longitude would correspond to 15 degree. This one longitude is equal to 15 degree, and that one longitude length would be equal to 1 hour. So we see that from this, about 1 degree would correspond to 4 minutes. So why is all this done? We know that in a day there are 24 hours. So it takes about 15 degree for Earth, that is, the Earth would cover an angle of 15 degree in this 1 hour. So it would cover total angle of 360 degree in 24 hours. So by this measure, we see that every 15 degree would correspond to 1 hour. So from this prime meridian, we take 15 degrees at certain intervals, that is 15 degree, 30 degree, 45 degree, and then 60 degrees, 75, etc. And each of these major longitudes would be equal to 1 hour. So from 0 degree to 15 degree, it would be 1 hour equivalent, and 15 to 30 it would be 2 hour equivalent, and likewise 45 would correspond to 3 hour equivalent. Likewise 5 something like 75 degree would correspond to 5 hour equivalent, and all these longitudes to the east corresponds to times ahead of Greenwich Mean Time. As Earth rotates from west to east, these are the eastern regions are the ones which receive earlier sunlight. As a result, these times are advanced to compared to Greenwich Mean Time. So it is plus 1 hour at 15 degree east, and plus 3 hours at 45 degree east, etc. Likewise, the same thing happens minus 15 degree because they are behind Greenwich Mean Time. So they are 15 degree minus 15 degree west, likewise minus 45 degree west, etc. would correspond to 3 hours, that is minus 3 hours. So by this we see that at 180 degree west it would be minus 12 hours, and at 180 degree east it would be plus 12 hours. So now we want to consider time at certain point, say about 90 degree east. Then we would see that 90 degree would correspond to 6 hours. So it would be, we call this as plus 6 hours GMT, Greenwich Mean Time. And if you take minus 90 degree west, that is 90 degree west, it would be similarly it would be minus 6 hours GMT. So that from this we have arrived at a uniform time system where we could tell the times of all the locations based on Greenwich Mean Time. And now, like we have a uniform time system, we would like to have a uniform date system too. For this, Earth is divided into two parts. One to the east of 180 degree longitude, and to the west of 180 degree longitude. And we see that 180 degree east and west longitudes coincides to a single line, which is exact opposite of the prime meridian. And we see that unlike prime meridian, the international date line follows a zigzag path. This is to see that the main regions belongs to certain regions would come under the same date line system. For example, this part of, if we take a straight line, it would pass through here, and this would be separated from the mainland Russia. That is the time, the date system for this region would be separated from the mainland Russia, and this would be some sort of inconvenience. As a result, to keep all the major regions which are part of different countries in uniformity, we have considered a zigzag international date line. So now this region would come under Russian date system, and the region like Aleutian Islands, which are for part of Alaska, which is a part of USA, would have their own kind of date system. If we cut this and give different date system for this and this, then it would be 1 day difference between these two regions, and it would be some sort of convenience for administration, etc. And to make life easier, we have made this line a zigzag path. And also there are certain islands in Pacific region which are also, for example, if they wanted to choose to be in the eastern side, they were kept in the eastern side by again curving this line. And according to convenience, we have formed this international date line. And if we just consider a person traveling from east to west and west to east scenarios, let's see what happens. See, this is globe. It is spherical in shape, unlike the previous map we have seen, which is just a two-plane figure. But now in a three-dimensional view, it would be different. Suppose it is Greenwich Mean Time is exactly opposite this line, international date line. And if a person travels towards west, that is towards USA and other countries, and crosses this international date line, then he would he would gain a day, because we know that sun rises in the east, that is it would rise in the east, so the day would start in the east and it would end in the west. So when a person moves from west to east, he would gain a day, and when a person moves from east to west, he would lose a day. Let's see why. We see that from the prime meridian, we take time as positive when moving towards east, and we take time as negative when moving towards west. For example, if a person travels all this way long, then it would be 12 hours ahead of GMT, and if he moves in this direction, then he would be 12 hours behind GMT. Hence there is about 24-hour difference to a point which is just east of GMT and to a point which is just west of GMT. That is, this whole path would take about 24 hours. Hence the time difference between east and west along this date line would be exactly nearly 24 hours. As a result, this eastern part would be a day ahead, whereas the western part would be a day behind with respect to international date line. So all the regions to the east of GMT, that is the prime meridian, they would be 1 day ahead. That is, this region would be 1 day ahead compared to this region which is west of GMT. So all the eastern part would be 1 day ahead and the western part would be 1 day behind compared to the eastern part. For example, if here it is 31st of December, that is in the eastern part, then in the western part it would be 30th of December, that is they would be 1 day behind. And soon when a person crosses from west to east, that is from western side to the eastern side, as in a sphere, it would be just like this. So you would gain a day, that is from 30th to you would reach 31st day. But at the same time, when a person starts from the west, that is starts from the east and reaches west, then you would shift from 31st day to 30th day, so you would lose a day. So this is how international dateline works. Now let us look at standard time. Each country has its own standard time zone. For example, India has its standard time zone at 82.5 degree east longitude, that is it is 5.5 hours ahead of GMT, that is plus 5 hours 30 minutes ahead of GMT. And England as its standard time zone along this prime meridian. Likewise, other countries like Brazil would have its time zone along 45 degree west. Sometimes as the country's extent, east-west extent is too lengthy, for example Russia, where it ranges about 165 degrees, the difference between this longitude and this longitude would be 165 degrees. Here it is not feasible to have a single time zone, as there would be huge time differences between one region to another. So these countries have divided, they have got multiple time zones. For example, Russia has about 9 time zones presently. Previously, when it was USSR, it had about 11 time zones. Likewise, Canada and USA, which are also have quite horizontal extent, that is from east to west extent, they are thousands of kilometers in length. So even in these countries it is not feasible to have a single time zone, as there would be huge time differences between different parts of the country. That is, the sunrise and sunset times would be much different. As a result, they have got multiple time zones. For example, USA has 4, and considering Alaska it has 5, and the Canada has 4 time zones, just like USA, the mainland USA. India is also has a longer extent. For example, it's spread across nearly 3,000 kilometers. But as the time difference between these two regions, that is Gujarat and Assam, is only 2 hours. We have chosen the central part, that is which passes near Allahabad in Uttar Pradesh. So the time difference between this one is 1 degree to the east, 1 hour to the east, and between Gujarat and this Allahabad is 1 hour to the west. So considerably it would only be 1 hour difference. But for Russia and all, it would be more than just 5-6 hours difference. So they have got multiple time zones, and these time zones are called as standard time zones. Few countries has only one standard time zone, whereas few mighty countries like China, Russia, USA, Canada, etc. has multiple time zones. So the latitudinal extent of Russia would be 165 degrees. For example, from this part, from the eastern end to the western end, that is eastern end to the western end, it would be 165 degrees. If suppose they chose something like, that is passes from the center or the middle portion as the time zone, then the difference would be about 80 degree to the west and 80 degree to the east, and 80 degree would correspond nearly to 4.5 to 5 hours of difference. As a result, for example, if it's morning here, it would be 7 o'clock, and if the same line is considered as a time zone, then even here it would be 7 a.m. But due to this extent, when it is sunrise here, it would be nearly sunset here. So this kind of a system is not feasible. Hence, they divided their countries into multiple time zones, so that this part would correspond to this time zone and the next part would correspond to this time zone. Though it has some certain administrative barriers like too much of confusion, but still, as these countries are too lengthy, they don't have any other choice. They have to follow this kind of a timeline. Now, if you take India, it is spread about 30 degrees. It has 30 degrees east to west extent. That is 30 degrees would correspond to nearly 1 plus 1, that is 2 hours, because 15 plus 15 degrees corresponds to 1 hour. So 30 degree would correspond to 2 hours. So the difference between Arunachal Pradesh and the parts of Gujarat would be about 2 hours. For example, if the sun rises here at 6 o'clock, it would be still darker here in Gujarat at 6 o'clock, and here the sunrise would be at 8 o'clock. So it is a considerable difference, but still, due to various constraints like illiteracy and other administrative problems, India decided to have a single time zone, that is at 82.5 degree east. And before independence, India has something called as Chai Bagan time system, that is eastern parts, that is Assam, Arunachal Pradesh, Manipur, etc., where tea plantations were extensive. The Britishers here followed Chai Bagan time zone, that is where this time zone is 1 hour ahead of mainland India's time zone. So they gained 1 hour. So 1 hour was a productive hour for this region. As a result, they could consider daylight saving system, where they could save the energy, that is nighttime burning of lamps, by 1 hour, so that and also productive time would be improved by 1 hour. But during recently, with the Chief Minister of Assam raising this issue, that is Tarun Gogoi, raised this issue and asked that the northeastern state, especially Assam, would have to have a different time zone, which is called as Chai Bagan time zone. Chai is tea and Bagan are the tea planters. So the time zone decided for tea planters was called as Chai Bagan time zone, and they wanted this kind of a time zone because they would get they could save 1 productive hour. But Indian government did not accept for this, and the Assam government said they would follow their own time system, where they would be 1 hour ahead of mainland India's time system. But it doesn't make a difference, because instead of starting school set, they would simply start school at 9 a.m. So they would obviously gain a day. Just simply by choosing 2 time zones, it would lead to more confusion among the literate population of this country.